Hello everyone, I'm Shuai Wang from Renmin University of China, and it's my honor to be here to introduce our work on the video memorability prediction. It's titled Primary Exploration because this is our first attempt to try to explore what kind of factors may affect or determine the memorability of videos or other media. I will introduce our work from these five parts, the framework, the multimodal features, and the fusion, and the experimental results and analysis. And the finally is the conclusion. From the very beginning, I will, in this memorability prediction task, intuitively we could think of these three kind of method. We could classify into a specific level, such as the high level, middle level, etc. And or we could use run a regressor to predict the specific value of the memorability score, or we could use a ranking model to use the comparison information. So finally, we simply use two kinds of regression methods: support vector regressor and random forest regressor. And for multimodal features, we use these four kinds of features, and including C3D, HMP, aesthetics, and I3D. The C3D, HMP, and aesthetics are officially provided in this task. And in addition, we extract the features from I3D in the RGB branch. And these four features considers such as motion, spatial temporal information, aesthetic factors, and so on. And for text features, we use glove as our word embedding, and use four sentence level encoding as our strategies to encode all the word embeddings in a sentence into a sentence level feature. And the average means we use the mean value of the word embedding of a single word, and in a sentence, and use the mean value as the sentence level representation. And the sieve, skip, sort, and the concept net is three kinds of sentence level encoding. We have two subtasks, long-term and short-term. So we intuitively we think there must be some or patterns between them. So we transform the original label exact value into a one-hot vector and append them to the end of each single features. These are three kinds of information we use. And for fusion, we use late fusion to fuse orders, and there are two strategies. The first one is simply to use the average value of all the single features. And the second is to design a second regressor. We concatenate all the scores of a single feature together and get a new feature and feed them into the second regressor, and finally we can get the final score. We split, given this development set, we split it into two parts: a training set and a local test set. The samples, this process is about this. We firstly rank the videos by their scores, the labels, and sample a video into the local test set every 4 videos. The hyperparameters are determined by grid search and five-fold cross-validation, and we use the SVR and RFR. There are all three parameters to be determined. We can see the picture and find the results. The word representation are all at the same level, and they all outperform the results or the visual features, and all the fusion of the features can achieve about 0.226. This is about in the long-term memorability task. And for the short-term memorability task, it has the same trend with the long-term task, and all of the fusion of the features can achieve about or for 0.472. These are the results on the official task set, and we can see that the label information did not work on the officially task set. We think maybe we could explore other formats or some methods to fuse them into the memorability prediction system. The M means we use the average strategy, and the S means the second layer regression strategy. The required means we didn't use the label information in the submission. These are some interesting samples we picked out from the dataset. The A and B are videos with both high long-term and short-term scores. We can see the first one, a man sitting on the beach with diving goggles and with the laptop on his lap. How to describe this picture? I think it's a little incredible or ridiculous, funny, interesting. And the second one is a sunset of father and son. I think this is about some aesthetic factors. And we can see the E, F, G, and H, these four videos. The metal swan, the toys on the desktop, and the hand playing a guitar. These are a close-up of something. And the tree, the picture E. I remember it's a moving camera, but it's always focusing on this tree. So I think these videos all has low long-term scores and high short-term scores. I think maybe there is something about focus can affect or determine the short-term video scores. So this conclusion, we utilized the regression to solve the memorability prediction task and explored the multimodal features, the visual and textual. And we found that the textual features show the best performance. Actually, this it's a little surprising. And the multimodal fusion boosts the results on the local test set, but not that significant on the official test set. And there are some patterns about the memorability, such as interestedness, objects, and the environments, or some the scenes, such as the a natural landscape or something other, and the close-up. So this is all my presentation today, and thanks for your attention.